Have you ever been so immersed in an activity that time seemed to disappear and everything felt effortless? This mental state, known as flow, is a peak performance condition where creativity, focus, and productivity reach their highest levels. Athletes, musicians, writers, and even scientists often describe moments where their skills and challenges perfectly align, leading to seamless and high-level execution. But what is happening in the brain during flow? Research in neuropsychology suggests that during flow states, the prefrontal cortex, the brain's self-monitoring system, temporarily quiets down, reducing self-doubt and overthinking. At the same time, dopamine, norepinephrine, and endorphins flood the brain, increasing focus, motivation, and even pleasure in the task at hand. Studies of elite athletes and artists show that their brainwaves shift into the theta and alpha ranges, similar to deep meditation, allowing them to react instinctively and process information faster. But can we train ourselves to enter flow more often? Some researchers believe structured training, mindfulness, and deliberate practice can increase the likelihood of experiencing flow. For example, extreme sports athletes often push themselves into challenging but manageable situations, fine-tuning their ability to stay in flow under high stress. In music and creative arts, setting clear goals and minimizing distractions can help induce flow more frequently. Even in everyday work or learning, people who find the right balance between skill level and challenge tend to experience flow more easily. Could this understanding be applied to boost human potential in education, work, and even artificial intelligence? If we could systematically harness flow, what new levels of creativity, innovation, and physical performance might we unlock? Flow is a psychological state characterized by complete immersion, heightened focus, and a sense of effortlessness in performance. It occurs when an individual engages in a task that perfectly balances challenge and skill, leading to deep concentration and intrinsic motivation. Flow is associated with decreased self-consciousness, altered time perception, and peak efficiency in cognitive and motor functions. Professional athletes describe being in the zone, where movements feel automatic and external distractions disappear, much like surfing a wave. Once caught, everything moves effortlessly, requiring only skillful navigation. During flow, activity in the prefrontal cortex, particularly the dorsolateral prefrontal cortex, DLPFC, decreases in a phenomenon known as transient hypofrontality. This downregulation reduces self-criticism, doubt, and cognitive inhibition, allowing for uninhibited creative and athletic performance. By silencing overactive executive functions, flow enables smoother, faster decision-making and intuitive actions. Jazz musicians and improvisation show reduced prefrontal activity, allowing spontaneous and creative musical expression, much like autopilot mode, removing unnecessary mental interference to allow seamless execution. Flow is facilitated by a cocktail of neurochemicals, including dopamine, enhancing motivation and learning, norepinephrine, increasing focus, endorphins, reducing pain and fatigue, anandamide, promoting lateral thinking, and serotonin, boosting mood. These chemicals create an optimal neurophysiological state that enhances performance and accelerates skill acquisition. The balance of these neurotransmitters determines the depth and sustainability of flow. Surfers report euphoric states when riding waves, attributed to the flood of anandamide and endorphins during flow, similar to tuning an orchestra, each neurochemical playing a role in creating a harmonious performance. EEG studies reveal that flow is associated with a transition from high delta brainwaves, linked to active thinking and stress, to low alpha and theta waves, which promote relaxation and heightened intuition. Theta waves, common in deep meditation and REM sleep, enhance creativity, problem-solving, and effortless action. The shift to mid-frequent oscillations enables deeper focus. Elite marksmen and archers show increased alpha wave activity just before executing a perfect shot, much like a perfectly tuned radio, reducing static to receive clear, uninterrupted signals. Flow emerges when an individual engages in an activity where the difficulty level matches their skill set. Tasks that are too easy cause boredom, while those too difficult induce anxiety. Maintaining the challenge-skill balance pushes the brain into a state of deep engagement, optimizing both motivation and performance. Video game designers create difficulty curves to keep players in flow, ensuring neither frustration nor boredom, much like adjusting bicycle gears. finding the perfect resistance level for smooth and efficient movement. Training the brain through mindfulness and structured practice increases the likelihood of accessing flow. Mindfulness reduces distractions, strengthens attention networks, and improves emotional regulation, all of which facilitate deep focus. Repetitive training and visualization techniques help automate complex actions, allowing the brain to enter flow states more reliably. Meditation and breath control exercises are commonly used by elite performers to prime their brains for flow, similar to laying a well-paved highway, reducing obstacles and enabling smooth, uninterrupted travel. Creativity thrives in flow, as reduced prefrontal activity allows unconventional ideas to form through associative thinking. The brain enters a state of hyperconnectivity, integrating diverse neural networks for rapid idea generation and deep immersion in artistic pursuits. Writers, musicians, and scientists often describe flow as an effortless state of creativity where ideas emerge seamlessly. Writers report losing track of time when deeply immersed in storytelling, a hallmark of creative flow. Similar to a waterfall, ideas pour effortlessly when the right conditions align. In athletes, flow enhances motor coordination by reducing unnecessary cognitive interference and increasing sensor-motor integration. The brain processes information more efficiently, optimizing reaction time, muscle memory, and real-time adjustments. Flow also dampens the perception of effort and pain, allowing athletes to push beyond perceived physical limits. Marathon runners often experience a second wind where exhaustion fades and effortless movement takes over, similar to a well-tuned race car, operating at peak efficiency with minimal resistance. Advances in neuroscience and AI are uncovering new ways to enhance flow through biofeedback, brain stimulation, and real-time monitoring. Wearable EEG devices and neurostimulation techniques are being explored to help individuals enter flow more predictably. Future research may unlock personalized flow optimization strategies for education, sports, and creative industries. AI-driven neurofeedback systems train users to recognize and replicate flow states by providing real-time brainwave analysis, much like a smart assistant, helping users access peak performance states with precision and consistency.